Welcome to our next seminar devoted to plants and phytosensing. Like I already said, the main goal of that seminars is to connect people to share experience in the community in different relations, for instance, to sensor, phytosensing technology, plant physiology, plant treatment. So the whole spectrum is huge. And today it's my great pleasure to present our colleague, student from National Formosa University in Taiwan, Sahir. Sa- I hope I correctly pronounce it now.
Yes, yes,
Yes, and he is working with phytosensing. I think it's your master thesis topic.
yes.
The master thesis, yeah. It's I'm extremely excited about this topic. It is about treating tomato and cucumber with trichoderma. It's currently this the fungal and bacterial inoculants are a very hot topic, and we heard that yesterday with Laurent. He also worked with bacterial inoculants. So it's my pleasure, Zaheer, to invite you, and please start your presentation.
Uh, First of all, thank you so much, sir, for giving me a time and a great opportunity to discuss and to share with you my problems, my research topics with you. So, my name is Zaheer. I am a master's student in National Formosa University, Taiwan. And my advisor name is Professor Lo, and I'm master student. So my research is application of phytosensing system on detecting the physiological sign of tomato and cucumber with the treatment of Trichoderma. So first of all, I want to explain some introductions of my research. Mm, all of peoples know that modern agricultures demand the sustainable and real-time monitoring tools to evaluate the plant's health under the biotic and abiotic stress. Traditional methods like visual scoring or chemical analysis are time consuming and may miss the early stress sign. So the cyber phytosensing systems offers a non-invasive, fast and sensitive method to measure the bioelectrical signals and reflecting the plant physiological status. So my motivation is that to know understand how plants respond electrically to incollinants like trichoderma, like fertilizers. So monitor the real time plant response to stress like fertilizer and drought, imbalance and light change, provide a novel tool for early plant stress and detection in sustainable agriculture. So there are some goals of my research. I want to detect and compare bioelectrical response of tomato and cucumber plants with the and without treatment of trichoderma and fertilizers. And I have also goals that I want to know to analysis how impedance and biopotential signals change under the stress condition like drought conditions and nutrients conditions to determine if cyber's phytosensing can survive as an early warning system for plants health and monitoring to interrupt the signal patterns, waves, ohms, resistance, voltage change, and correlate them with the plant physiological processes. So these are some research goals of my research, and now I want to request the sir to cybers explain some solution I of some problems. I'm researching, so I am facing some problem related to device and my computers. So I did some research experiment in greenhouse and in my lab. So after complete my experiment, so when I see look and results, so I result some problems and some solutions. So I want to discuss with you based on the initial trials experiment after the applying the trichoderma with the sports of 10/7 impedance signals in the cucumber plant show a sharp change within the 12 to 24 hours, and that one the indicating physiological shifts. If I want to show like that, I started my test. During the first day, I did not apply the trichoderma and fertilizers, and I did not add a water. So after 5 to 6 days, I add trichoderma. So the channels 1 and 2 is moving with smooth size. So it indicate that they are changing physiological shifts. So treated plant exhibited higher electrical activity stability compared to control, suggesting improved stress. Voltage and impedance graphs show distance waveform in treated versus untreated plants. Under the drought stress, treated plants maintain more stable signals curve, possible reflecting the enhanced water retentions or water reduced transpirations. This is the result of my initial experiment, and this is the control plant. When I applied it, so start test, so I add water. After some days, 7 days to 6 days, these results I receive from the cyber's phytosensing systems. During start, what plants have more water. As the day by day, water plants need more waters, so the signal is going down by dawn. This is a treatment plant of Tachoderma, and this is when I started plants. So I add water. So after 1 and 3 days, I did not add water. So I applied only Tachoderma. So the results are same. Now, I want to request, sir, please advise and suggest this and teach us how we fix device with plants and with computers. So everyone, I know that not properly know which parameters like plant electrophysiological activity, electrical conductivity can measure with the help of impedance and biopotential electrodes, and also tell us how much distance between one electrons to the other electrons and one channels to and the other channels in the plants stem and roots, and how to set up of impedance like plot setups, lp filters, frequency minimum and maximums, and dds type and systems likewise. So there are some graph that I received from the articles, but I did not understand the effect of these, like how to describe the waves down and up. Sometimes the channel one is show downside, and sometimes channels one is show the upside, like this. So what is mean of these values, like 450, 4050, likewise, and some devices have some different values for every plants. So I requested, sir, please describe and understand, teach us how to identify and how to explain these values and these channels when it come down and when these channels come up. So thank you, sir.
Thank you again for this presentation. It's absolutely clear, it's probably not the, let's say, final presentation. Your study is in progress. So, but
Yes.
question is still for analyzing data, phytosensing provide only some numbers, without any meaning.
Yes.
And for them, you need biological model. Which biological model did you use to evaluate your data?
Biological. Sir, we have two to three models, I think, but we using only one models. Her name, the device's name. Are you asking about device's name?
No, for instance, if you're measuring water state, because if you apply impedances, you're measuring water state in the stem. So how much water, for instance, in particular region, how is oncoming water, upcoming water, water balance. To understand this, you need the model that say you, for instance, if you apply trichoderma, it change water balance. So more water incoming in plants, for instance.
Uh, Basically, we want to know about the physiological effect of plants to effect of trichoderma. So we are doing trying the biopotential and impedance test.
Okay, then
Understand?
what is more useful, impedance or at least biopotential in this preliminary study?
Biopotentials.
Biopotential, oh, this is interesting.
Yeah.
And in biopotential, what do you receive? It's more
Uh,
clear output.
we did not receive yet properly results.
Okay, okay,
Sometimes it's working, sometimes it's not working. So
okay.
then I try to impedance. So impedance is working properly.
But for instance, impedance, we also work with inoculants, with fungal and bacterial inoculants. And what we see, they provide more faster biomass growth. So they grow faster.
Yes.
Grow faster mean you receive more water. So you see more water in tissues. And so theoretically impedance should grow also go down. So because of more water. And you can evaluate, well, plants are growing and they receive more water. Did you observe something like this?
Yes. When I add waters with the inoculations like bacteria, so the plants grow mostly, and the channels is going up, and frequency and the value voltage is also increased step by step.
But if more water, the impedances, they should go down because more water mean less resistance, so it
Yes.
should go down. Yeah.
So
Uh,
yeah.
um, Another question, trichoderma. As we discussed, you said you apply trichoderma and you wait some period of time. How long is this period of time if you see the symbiotic development?
About 1 days, about 1 to 2 days.
1 2 days, so fast.
Yes. Yes.
And you use soil based grow with soils.
Yes.
Yeah, with soils. Yeah. Okay.
Sorry.
And you apply trichoderma with water solution, so you just irrigate.
No, I applied with the water solutions.
Fast. I mean, 1 2 days really fast. Typically, we
Yes.
wait in our setup. We wait for bacterial inoculants something like 3 days, 3 4 days probably until we see this fully developed effects. Okay, then
Okay.
this grows. Did you test somehow biomass grow? Let's say in any secondary approaches.
Sorry, sir. Did you biomass?
um, so if you apply inoculants, the more faster biomass grow. So how we do this, for instance, we measuring with impedances, we measuring water content, so we see more water in tissues. So then
Yes.
we measuring biomass. So with dielectric spectroscopy, we measuring biomass grow, and then, for instance, we can cut plants and measuring dry biomass. So we can correlate multiple values, and so we see is indeed biomass is growing. Have you
Okay.
done something like this?
No, not we done like this.
But you will probably do this, yeah, to correlate
Yes.
multiple values, yeah, 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 yeah.
Yes.
I think this is really important because you know each of these physiological parameters is specific, and to get the full picture, you need to correlate different values and different devices. Yeah. Okay. Now question is to more water. You say that you have tested irrigate water deficit stress.
What?
What's your result?
Uh, can you show?
Yeah, yeah, yeah.
Okay. Sir. Can you see?
Yeah, yeah, I can see. Yeah.
Okay. Sir. Uh, During the test, I did not add water. So after 3 to 4 days, I add water from there. There. So these channels is going to up. It's mean plant receive more water from there from the last 5 and 6 days. But in the starting days, I did not add water, so plants need more waters more than 1 days, 2 days. But I did not add water because I want to see how many days plants need water and how many days plants can survive without waters. So after 3 to 4 days plants is starting to die, so I add water. So when plants receive water, though they show properly growth after 5 days.
What I see here, this black curves, circadian rhythms. You know, one
Mm.
of properties if plants is working in proper way is circadian rhythms. And you see, if you in the first 2 days you see these circadian rhythms, then without water, no circadian rhythms, and with water, again appearance of circadian rhythms. Probably this is a characterization of water deficit stress.
Right, sir.
So properly, you know, it's another point. If you add water, typically impedance goes down. If impedance goes up, it means less water in tissues because
Yes.
of this dependency. But here is more specific. Is in fact appearance of circadian rhythms. Uh, we, we,
Right.
we, we had a very similar observation. If you remove water, so first of all, plants dry out, so its impedance is increasing. But the most important physiological sign, just I mean, a disappearance of rhythms, any rhythms.
Okay.
So that's probably one of points.
Fine.
Okay. Then at least there is from my side is all. Please share. I mean your final result of your final research. So we will try
Sure,
to
sir.
try to support you. Generally, I mean
Yes.
this inoculant story is extremely top, also hot.
Mm.
You know, you can improve water balance. You can add additional substances. I think it's really exciting topic. So we have also new electrodes, so clip electrodes. Probably just check. They probably they will be more suitable for you because there are some so woody tissues, especially in tomato plants, in the lower part of tomato plants. This clip electrode will be more suitable.
Okay.
Because you know you receive devices a couple of years ago. I think something
Yes.
like 5 years ago.
5 years ago.
Yeah, five
Yes.
years ago. Just I mean,
5 to 6 years.
check new electrodes. So and they're also stable for outdoor conditions. So you can perform experiments in the greenhouse and outdoor, and see
Okay.
different stresses. For instance, it's important if you combine water deficit stress and heat stress. So plant
Nice.
physiology gets crazy. You will see a lot
Yes.
of unusual measurements. And these four clip
Mm.
electrodes, the stainless steel, they are really stable. So probably I mean check new electrodes.
Okay.
Okay. Then I wish you anyway good luck in your research. Thank you for sharing
Thank you.
your results. So it's
Thank you.
very nice. And then let us know what will happen with your findings.
Sure.
Okay.
Okay.
Okay. Then thank you. Then see you next
Okay.
time. Yeah.
Okay. Thank you.